So much like we've looked at the development of the atomic model, we're going to look at the development of the periodic table and the work of one man in particular, a Russian scientist called Dmitri Mendeleev. So in the year 1869, there is roughly about 50 or so elements that have been discovered. This is less than half of the number today. But Dmitri Mendeleev sorted these elements into groups based on properties and put them in a table. So this means elements of similar properties were put into the same group. And so these groups are the same sort of groups that we have nowadays, which are just like vertical arrangements. But he also did this based on the properties of the compounds that were formed from these elements. So not just the properties of the elements themselves. But Mendeleev realized something, and that was that if you arrange these elements in order of increasing atomic mass, then a pattern appeared, which was that the elements of similar chemical properties more or less seem to appear in their own columns, or their own groups. Now, looking at the table today, we know this is how it is arranged. But the elements weren't arranged perfectly back then, even after Mendeleev's realization and from him putting together a table. So using just the atomic mass to arrange these elements horizontally meant that some elements didn't quite fit into groups which were vertical based on chemical properties, and some elements ended up in the wrong groups. And this was often the case because of isotopes. Now, it's important to point out that the atomic mass is not the same as the atomic number. The atomic number today obviously means the number of protons that an element has. But we're in 1869 and the proton hasn't been discovered yet. So atomic mass, as far as Mendeleev is concerned, just means the mass of the element, or the mass of the atom that he finds to represent the element. He also presumably didn't know that we had these things called isotopes, and because we did, for many elements we have atoms with different masses, so arranging the elements purely by its atomic mass meant that some elements ended up in groups which did not reflect its chemical properties. So to get around this, Mendeleev basically moved some elements into different groups with other elements of similar chemical properties. So after he switched the order of the elements to keep those with the same properties in the same columns, he actually left gaps in the periodic table. And the reason he did that was because he knew it was more than likely that there were some elements which hadn't yet been discovered. And so he left gaps in the table for these elements for when they eventually were found. So, crucially, what this meant was that Mendeleev was able to predict the chemical and physical properties of undiscovered elements. So, for an undiscovered element in a group, what he could do was look at the physical and chemical trends of the rest of the elements in the group, and then make predictions about the ones which weren't yet found. So this one here, right above aluminium, he actually predicted, amongst several other elements, one which was called aluminium. This is now known as gallium, and you can go and check it in the modern periodic table. But he was able to make quite accurate predictions about this element before it was even discovered. And as more and more elements were found, the gaps were filled in until the table as we know it was formed.